So this project doesn't have funds from the Forest Growers Levy. The work has been funded by C3. This presentation is by myself and by Jeff McIver. Jeff is the smart guy within C3 that's done most of the tech work. It's also a project that Callaghan Innovation have been involved, their computer vision group have been involved with us for the last 6 years. So it's about an assessment of a semi-automated system for counting, measuring and tracking of export logs. So who are C3? C3 are New Zealand's largest on-wharf logistics company. They handle a wide range of products and they operate in 15 ports in New Zealand and Australia. How important are logs to C3? Well, logs are C3's largest cargo by volume. And just to give you an idea, in the last 8 years, they've tagged, measured, handled and tracked over 100 million tonnes of logs and 260 million individual logs. And so they have information recorded on every one of those 260 million logs. So what's the current system for tracking and measurement? So what happens is when the truck pulls up at a scaling shed at the port, the truck driver gets out, hands the people in the port a docket, in the scaling shed a docket that's got the length and the grade on it, and it's also got the number of logs. The person scaling the logs gets the same number of tickets as it says that there's logs on the truck and goes out and applies those barcode tags to the logs, and that's when you find out if the log count is right or wrong, and most of the time it's wrong, and in which case the guy has to go back into the shed, get some more tickets if he needs some, or if he's got extra tickets takes them back and gives them back into the system, each time waiting in line. They measure small end underbark diameters, then the log volumes are scaled using the JAS scaling system, and then from that the truck is then sent out to a storage row, so logs are then unloaded. When it comes time to load the ships, the logs are moved from the row to Shipside, either on a truck that can be used on the port or often with a large loader. And then that loader puts the logs into a bunk, and you can see a person in there standing beside the bunk. He counts all of the logs, counts them again, and then they also measure or they read the ID tag on the log that's put in. Why do they have to count as well? Because occasionally tags get knocked off and they've got it. What do you do if there's 38 tags and 41 logs? You've got to know that. So when the logs go into the holder on the ship, one of the things that you need to know, you need to make sure, is that the right volume from the right supplier will end up at the right destination. And to do that, every log has to be accounted for. You have to know where every log is stowed, and that means that every log really has to be ID'd. So C3's challenge was they wanted to improve their customer service, and they wanted to do that through increasing the throughput of the trucks, speeding up the tagging and the measurement time. They wanted to increase vessel loading productivity. They wanted to increase the integrity of their data, and they wanted to improve the safety hazard environment. It's really dangerous on the ports. And they wanted to provide an innovative solution and services to an international marketplace. So the system that they developed is called COMETS, and that stands for Count, Measure and Track Simultaneously, looking for one system that could do it all. So the vision back in 2013, and this project's been going on for a number of years. We thought we'd have it sorted out by 14 or 15, and here we are at 18, and it takes time. But the vision was to have a system where the scaler is wearing a computer on his belt. He's got some sort of sensor system for doing a measurement, some sort of interface so he could see what's going on. Information would be squirted wirelessly to a really grunty graphics processing unit. So that was the system. On the way to getting there, there were a number of things that were developed. One of them was improved counting, so that when the truck arrived, they knew how many logs it really had on. So they developed what they call their bush docket system, which is a smartphone app. The truck driver takes photos of each packet of logs, and that information is squirted to the scaling shed before he even turns up, and then it's got the real count of the logs. And this truck had 3 packets of logs on it. The total count was 181. And I don't know whether you've ever driven behind a logging truck and tried to count the number of logs, that you give up after a very short time. Getting a good count is difficult, but this system really reduced the number of times that they would have to go in and get extra tickets, so sped up that side of things. And the same system improved the log count at Shipside, so using an automated system for finding those logs and counting them. So, it beat me. So it shows both the new system, and you'll see the old system as well. So this is putting the new system on. So it finds the underbark diameter and automatically determines what's the smallest and largest diameter. This is the current system. You can see the current system is a two-handed system to start with, and is, yeah, you'll see it's not as fast. And that's what the scalers think about it. The smile on their face is that, you know, that this is a much better system than what they're dealing with. So what we did is, this was a few months ago now, we set up an operational trial to assess the accuracy in terms of precision and bias of the latest version of Comets in an operational trial, and compare it with the current manual scaling system. We wanted to know also what sort of efficiency gains resulted from the use of Comets compared with manual scaling, and we wanted to build up a large operational data set for machine learning and testing of future software improvements. So for this trial, 30,000 logs were ticketed and measured over a 4-month period. And this is one of the things I love working with private industry. As a researcher, you normally, if you get 100 logs or 200 logs, then you're lucky. You know, to have a trial of 30,000 logs, that was just excellent. Each log was scaled using the current manual system, and we also scaled those logs using Comets. And then a random subset of 898 logs were check scaled by an expert scaler. That's the gold standard. So under the system, normally when logs are scaled, a subset of them are check scaled to make sure it's like a quality control system. And so the check scaler, the expert scaler, he takes more care, has a much better look at those logs. So that was our gold standard. And one of the things I will say is the gold standard is still a person who is imperfect. But So for the trials, just to put things in perspective, the maximum bias that's allowed for logs scaled on truck or on rail wagon is plus or minus 3% volume. It's sometimes difficult to get a good lock at logs, and so that's what's acceptable. For the trial that we did, compared with the check scaler, manual scaling overscaled volume by 0.88%. So certainly within that 3%. So that was good. Compared with the check scaler, Comet's underscaled volume by 0.04%. So it was just about perfect. That's as far as bias is concerned. One of the other measures of acceptability is what they call precision, and for that, what's required is 62.5% of the logs, the diameters that are measured by the check scaler and the scaler, or in this case Comets, are expected to be the same, at least 62.5%. And at least 95% of the logs are expected to be within plus or minus 2 centimetres. And you can see that the manual scalers, they certainly met their requirements, that they had more than the 62.5% and they had more than the 95%. But you can see that Comets was even better, that it had an even higher proportion of logs that were the same, and certainly just short of 100% that were within plus or minus 2 centimetres. Right, okay. Efficiency. So time studies were carried out using video footage. There were video cameras in the scaling shed, and we also scaled in the rail yard, and so that was just me out there with a stopwatch in my hand. We did 42 railway wagons and 54 truckloads normally, and then 40 rail wagons and 26 truckloads with Comets, and we compared the results in a minutes per log and a minutes per jas cubic metre basis. The blue is Comets, the other colours, the manual scaling system, and you can see that for rail and for truck and for the different log lengths, the Comets was always faster than manual scaling. So the concluding comments from the trial was that the Comets was less biased and more precise than the current manual scaling system, and it was more efficient. It was 14 to 46% faster than the current manual scaling system. So where to next? So all of the work was done on a single log grade. It was the most common log grade that's exported. Where we've moved on to is looking at a greater range of log grades. We also want to make the system more portable. At the moment, it depends on having access to good grunty graphics machines nearby. Integrating it into C3's business, there are 40 of these tools being rolled out just after Christmas. Continuous improvement, the project is still going on, and the automated scaling is, at the moment, we've still got a person doing this. It's possible that at some stage that we'll go to a fully automated system, but we've got a system now that having the people involved is really helpful when you get to the super ugly stem that no system that can deal with. You've still got a person there that can override if necessary. And that's it.